Learning objectives. We will discuss the following topics in this chapter: Introduction to Natural Language Processing, Syntactic Processing, Semantic Analysis, Parsing Techniques, Context-Free Grammar, Recursive Transition Nets (RTN), Augmented Transition Nets (ATN), Case and Logic Grammars. Introduction to Natural Language Processing. What is Natural Language Processing (NLP)? NLP are the languages of human being. NLP includes everything for the understanding of the computer language, typed or spoken, and also generate the natural language. NLP is a subdivision of artificial intelligence and linguistics, devoted to make computers understand statements written in human languages. Natural language. A natural language is a language that is very well spoken, written by humans for general communicative purpose. It is also known as a living language. Example: Tamil, Hindi, English, French, etc. A language is a system, a set of symbols, signs, or grammar. The symbols are combined to convey new information. The rules govern the manipulation of symbols. Natural Language Processing (NLP). Natural Language Understanding (NLU). The NLU task seeks understanding and reasoning while the input is a natural language. Natural Language Generation (NLG). NLG is a subfield of a natural language processing. NLG is also referred to the text generation. Steps of Natural Language Processing (NLP). Morphological and lexical analysis. The lexicon of a language is its existing vocabulary that includes words and expressions. Morphology is the identification, analysis, and description of structure of words, otherwise known as the study of words. The words are generally accepted as being the micro-units of sentence. The syntax refers to the rules and principles that govern the sentence structure of any individual language. Lexical analysis. The aim is to divide the text into paragraphs, sentences, and words. The lexical analysis cannot be performed in isolation from morphological and syntactic analysis. Syntactic analysis. Here, the focus fell on how the words form together to make a sentence and the analysis of words in a sentence to find out the grammatical function and structure of the sentence. The words are transformed into structures that show how the words relate to each other. Some word sequences may be rejected if they violate the rules of the language for how words may be combined. Example: an English syntactic analyzer would reject the sentence "boy, the go, the toe, store." Semantic analysis. It brings out an absolute meaning from context. It determines the possibility of deriving meaning of a sentence in a context. The structures created by the syntactic analyzer are assigned meaning. Thus, unless a mapping is made between the syntactic structure and objects in the task domain, it will be rejected. Example: the sentence "colorless green ideas" would be rejected as semantically anomalous because colorless and green make no sense. Discourse integration. The meaning of an individual sentence may depend on the succeeding sentences and may influence the meaning of the sentences which precedes. Example: the word "it" in the sentence "you wanted it" depends on the prior discourse context. Pragmatic practical analysis. It derives knowledge from external common sense information. It means understanding the purposeful use of language in situations, particularly those aspects of language which require world knowledge. What was said is reinterpreted to determine what was actually meant. Example, do you know what time it is? Should be interpreted as a request. Formal language. Formal language, simply language, is a set of strings over some finite alphabet sigma. Formal language is described using formal grammars. Symbol is a character, an abstract entity that has no meaning by itself. Example, letters, digits, and special characters. Alphabet is a finite set of symbols. An alphabet is often denoted by sigma. Example, B is equal to 0, 1 says B is an alphabet of two symbols 0 and 1. String or a word, finite sequence of symbols from an alphabet. Example, 0, 1, 1, 1, 0 and 1, 1, 1 are strings from the alphabet B and above. Language is a set of strings from an alphabet. Linguistic and language processing. Linguistics is the scientific study of language. The following are its micro-components: sounds, phonetics, word formation, morphology, sentence structure, syntax, meaning, semantics, understanding, pragmatics. The levels of linguistic analysis are shown here. Higher level corresponds to speech recognition, SR. Lower level corresponds to natural language processing, NLP. Defining terms related to linguistic analysis. Phones. The phones are acoustic patterns that are significant and distinguishable in some human language. Example, in English, the L sounds at the beginning and the end of the word loyal are termed light L and dark L by linguistics. Phonetics expresses how acoustic signals are classified into phones. Phonology tells how phones are grouped together to form phonemes in particular human languages, or else it is the study of phones. Strings. An alphabet is a finite set of symbols. Example, English alphabets A, B, C, D, E, F up to Z. A string is a sequence of symbols taken from an alphabet. Lexicon. Lexicon is collection of information about words of a language. Example, pig is usually a noun but also occurs as a verb and an adjective. Words. Word is a micro unit of a language which carries meaning. Example, walk, think. Words build phrases, which in turn build sentences. Determiner. Determiners occur before the nouns and indicate the noun's reference. Example, the boy, our car, both colleges. Morphology. Morphology is the analysis of words into morphemes and conversely the synthesis of words from morphemes. One among the smallest meaningful units in the grammar of a language. Example, unbreakable has 3 morphemes. Un, bound morpheme, prefix, able, bound morpheme, suffix, break, free morpheme. Syntax. Syntax is the structure of a language. Syntax is a finite set of rules that specifies a language. Syntax is represented by parse tree or by a list. Semantics. Semantics is a meaning of words or group of words, phrases or sentence. Pragmatics. Pragmatics tells how language is used in a day-to-day practical life, that is, meaning in context. Example, if someone says the door is open, it is necessary to know which door the door refers to. Augmented transition nets. An augmented transition network, ATN, is a recursive transition network which can perform tests and can take actions during arc transitions. An ATN uses a set of registers to store information. A set of actions is defined for each arc, and the actions can look at and modify the registers. An arc may have a test associated with it. The arc is traversed, and its action is taken only if the test succeeds. When a lexical arc is traversed, it is placed in special variable asterisk that keeps track of the current word. Context-free grammar. In a formal language theory, a context-free grammar is a grammar where every produced rule has the form capital A implies small a, where A is a single symbol called non-terminal and small a is a string that is a sequence of symbol of terminals and or non-terminals, possibly empty. The terminal and non-terminal symbols are those symbols that are used to construct production rules in a formal grammar. Terminal symbol. Any symbol used in the grammar does not appear on the left-hand side of some rule, that is, has no definition, is called a terminal symbol. Terminal symbols cannot be broken down into smaller units without losing their literal meaning. Non-terminal symbol. Symbols that are defined by rules are called non-terminal symbol. Each production rule defines the non-terminal symbol. The above rule states that whenever we see an capital A, we can replace it with small a. If a non-terminal may have more than one definition, we use symbol OR, such as the union operator. Example 1. Small a implies alpha or beta. States that whenever we see capital A, we can replace with alpha or with beta. A special non-terminal is called start symbol, usually written as yes. The production rules for this symbol are usually written first in a grammar. How grammar works. Grammar starts with start symbol, successfully applies the production rules until it reaches to a word which contains no non-terminals called as derivation. Anything which can be derived from the start symbol by applying the production rule is called sentential form. Any grammar may have innumerable sentences. The set of all such sentences is the language defined by that grammar. Example of grammar. S implies XC, X implies YX, Y implies A or B. The above grammar shows that it can derive all words which start arbitrarily, having no rule to be called as such, and have many small a's or small b's and finish with a small c. This language is defined by the regular expression A or B asterisk C. The asterisk indicates that the character immediately to its left may be repeated any number of times, including 0. Thus, AB asterisk C would match AC, ABC, ABBC, ABBBC, and any string that starts with an A is followed by a sequence of B's and ends with a C. Regular expression. Every regular expression can be converted to a grammar, whereas not every grammar can resume to a regular expression. Regular grammars. A regular grammar is a grammar where all the production rules are one of the following forms, where A and B represent any single non-terminal. Small a represents any single terminal or the empty string. Parsing techniques. Parser. A parser is a program which accepts as input a sequence of words in a natural language and breaks them into smaller subdivisions, nouns, verbs, and their attributes, to be managed by other programming. Parsing. Parsing can be defined as the act of analyzing the grammatically of an utterance according to some specific grammar. Parsing is the process to check that a particular sequence of words in a sentence corresponds to a language defined by its grammar. Parsing means how we can gradually develop from the micro aspect, symbol of the grammar, to the sequence of words using the production rules. The output of a parser is a parse tree. Parse tree is a way of representing the output of a parser. Each phrasal constituent found during parsing becomes a branch node of the parse tree. The words of the sentence become the leaves of the parse tree. There can be more than one parse tree for a single sentence. To parse a sentence, it is necessary to find the etymology and origin of sentence. There are two ways to do: top-down parsing, bottom-up parsing. Top-down parsing. Begin with the start symbol and apply the grammar rules forward until the symbols at the terminals of the tree corresponds to the components of the sentence being parsed. Bottom-up parsing. Begin with the sentence to be parsed and apply the grammar rules backward until a single tree whose terminals are the words of the sentence and whose top node is the start symbol has been produced. Note: the choice between these two approaches is similar to the choice between forward and backward reasoning in other problem-solving tasks. The most important consideration is the branching factors. Sometimes these two approaches are combined into a single method called bottom-up parsing with top-down filtering. Modeling a sentence using parsing structure. Every sentence consists of an internal structure which could be modeled with the phrasal structure. Algorithm. Apply rules on an preposition. The base preposition would be S, the root, that is the sentence. The first production rule would be NP is equal to noun phrase, VP is equal to verb phrase. S implies NP, VP. Apply rules for the branches. NP implies noun, VP implies verb, NP. The verb and noun have terminal nodes which could be any word in the lexicon for the appropriate category. The end is a tree with the words as terminal nodes, which is referred as the sentence. Example. Sentence: he ate the puri. Apply the grammar with the rules to analyze the immediate constituents of the sentence. S implies NP, VP. NP implies PRO. NP implies ARTN. VP implies VNP. The lexicon structure is ate, V, he, pro, puri, N, the, art. The parse tree is pro, V, art, N, lexical non-terminals. S, NP, VP, phrasal non-terminal. He, ate, the, puri, words or terminal. Recursive transition nets. A recursive transition network consists of nodes, states, and labeled arcs, transitions. An RTN can have 5 types of arcs. Cat. Current word must belong to a category. Example, verb. Word. Current word must match label exactly. Example, dog. Push. Named network must be successfully traversed. Jump. Can always be traversed. Pop. can always be traversed and indicates that input string has been accepted by the network. One state is specified as a start state. A string is accepted by an RTN if a pop R is reached and all the input has been consumed. Example: the metal can was dark blue. The ART, metal, adjective, noun. Can, verb, noun. Was, verb. Dark, adjective. Blue, adjective. The metal can was dark blue. The metal can was dark blue. There are no words left, so the pass is successful. Semantic analysis. Semantics. Semantics is the meaning of words, phrases, sentences, or whole texts. Normally, semantic is restricted to meaning out of context. That is, meaning as it can be determined without taking context into account. Semantic analysis. It derives a literal dictionary definition meaning from context. It determines the possible meanings of a sentence in a context. The structures created by the syntactic analyzer are assigned meaning. Thus, a mapping is made between the syntactic structure and objects in the task domain. The structures for which no such mapping is possible are rejected. Example: the sentence colorless green ideas would be rejected as semantically anomalous because colorless and green make no sense. Syntactic processing. Syntactic processing converts a flat input sentence into a hierarchical structure that corresponds to the units of meaning in the sentence. The syntactic processing has two main components: grammar, parser. Grammar. It is a declarative representation of syntactic facts about the language. It is the specification of the legal structures of a language. It has three basic components, namely terminal symbols, non-terminal symbols, rules, that is productions. Parser. It is a procedure that compares the grammar against input sentences to produce a parsed structure called parse tree. Example: llama pick up ball. Conclusion. In this chapter, we have covered the following in detail: Introduction to Natural Language Processing, Syntactic Processing, Semantic Analysis, Parsing Techniques, Context-Free Grammar, Recursive Transition Nets (RTN), Augmented Transition Nets (ATN), Case and Logic Grammars.